So here we have our first example. We're trying to solve for x. And we have tangent of x is equal to 3 over 5. So tangent of some angle measure is equal to the opposite over adjacent side lengths. And we don't know how to solve for x because when we've seen this situation before, right, we would just type in tangent of whatever the angle measure is, and that helped us solve for one of the missing side lengths. But in this case, since we're trying to solve for x, we have to take tan inverse of both sides. So see, I took tan inverse of tangent of x, set equal to tan inverse of 3/5. And I just scratched that out since I didn't have enough space to write tan inverse there. The tan inverse of tan of x is actually just simplifying to x. So that's going to leave us with x equal to tan inverse of 3/5. So to type that in your calculator, you're going to do second tangent and then 3 divided by 5 and close your parentheses. Yeah, closing your parentheses doesn't really matter for this problem, but we want to get into good habits so when problems get more complicated, you don't make some careless mistakes just because you forgot to close your parentheses. And when you do that, you're going to find that x is approximately 30.96 degrees. So x is approximately 30.96 degrees. So just to show you like what this is meaning in a picture, I'm going to draw the triangle that's representing this situation. If you drew it, it might look slightly different, but basically what we have is we have an angle measure. And if we're taking tangent of x, then we know that the opposite side length is 3 units long, and the side adjacent to that angle measure is 5. And so when we solve for x, we find that this angle is about 30.96 degrees. So I just want you to make sure you see some context towards what we're doing and not just like memorizing steps to the problem. So here's another problem. We have a right triangle and 2 side lengths. This is perfectly set up for us to be able to find missing angle measures. So it actually doesn't matter which angle measure we find first because we can, if we wanted to find this acute angle measure here, we have the side opposite to it and the adjacent. So we could take tan inverse of 24 over 25 to get this angle measure. Or we could solve for this angle measure first, and we have tan inverse of 25 over 24 to get this angle measure. So it doesn't really matter. I'm just going to solve for the angle on the top for the purposes of this video. All right, so I know that I'm solving for x, and I have the opposite and adjacent side lengths, so I need to use tangent. And so that's going to be x equals tan inverse of 24 over 25. Notice in this case, I kind of just skipped some steps. I didn't write tangent of x equals 24 over 25 and take the tan inverse of both sides, although you could do that. I just wanted to show you a couple different options for you to decide which way makes more sense to you. At this point, I would type in tan inverse of 24 over 25 in my calculator and solve for x. When I do this, I find that x is approximately 43.8 degrees. Make sure that you're remembering that if you round, to put an approximate symbol, and if you're talking about angle measures, that you put your units, in this case, degrees. So I could use a trig ratio to solve for the other missing angle measure that I'm going to call y. And like I said earlier, if I did that, I would just do that y is equal to tan inverse of 25 over 24. However, that's not really efficient, and math is about efficiency. So since I already solved for an angle measure, I'm going to use the triangle sum theorem. That's so much easier, right? I know that all these angles add up to 180 degrees. I already know that I have a 90-degree angle here, so x plus y must equal 90 degrees. So I'm just going to subtract 43.8 degrees from 90 degrees to solve for y. And in this case, since I'm subtracting a rounded value from 90 degrees, the answer that I get here is also going to be an approximation. So y is approximately 46.2 degrees. And if you did use your inverse trig ratio to solve for y, you should also find that y is approximately 46.2 degrees. So this problem tells us to find the angle measure to the nearest degree. So we have sine of j is equal to 0.4848. So we're trying to solve for j, that angle measure. And 0.4848, that looks so different than what we've seen before. But we know that sine of an angle is just equal to the ratio of the opposite over hypotenuse, right? And so whatever the length the side opposite j is and the hypotenuse, when you divide those two numbers, it's going to simplify to 0.4848. So even though it looks a little different, it's still representing the same thing. So if I want to solve for j, I'm going to have to take the sine inverse of both sides and then use that in my calculator to solve for j. So I get sine inverse of sine of j is equal to sine inverse of 0.4848. The sine inverse of sine of j just simplifies to j. And the sine inverse of 0.4848 rounded to the nearest degree, as the instruction said, is going to be approximately 29 degrees. All right, next example. So in this problem, we want to find the indicated angle measure rounded to the nearest degree. So I'm going to kind of list this out like I did for the trig ratios and see if that helps you see the problem in a different way. So I know that theta is going to be equal to a question mark, what we don't know. We don't know the length of the hypotenuse. We could figure it out, but like, why do that extra work when we don't need to? We know the opposite side is 27 units and the adjacent side is 38 units. So since I don't know anything about the hypotenuse, I don't want to use sine or cosine, so I want to use tangent. So I'm going to set that up and then take the tan inverse of both sides. So we're going to have tangent of question mark is equal to 27 over 28. When you take the tan inverse of tangent of question mark, you're just going to get question mark. And then you get tan inverse of 27 over 28, which you need to just type in your calculator, make sure you're in your degree mode, and solve for question mark. After you round to the nearest degree, you're going to find that that missing angle measure is approximately 35 degrees. Here's our last example. This problem actually lends itself to a lot of openness, lots of different ways to solve, because in this case, we have all three side lengths. So if we're trying to find x, then we could use any of the trig ratios. So I'm going to show you all three ways we could solve here, and you can just decide which way is easier for you. So I just listed over here that we have 3 is the side opposite to x, 5 is the hypotenuse, and 4 is the adjacent side. So over here we have x is equal to sine inverse of 3 over 5. X could also equal the cosine inverse of 4 divided by 5. And finally, you could find it by doing x equals tan inverse of 3 divided by 4. And no matter which three of these inverse trig ratios that you use, you should find that x is approximately 36.87 degrees. So there's an introduction and some examples of inverse trig ratios. If you have questions, talk to your group, watch some more videos, come talk to me, and practice some problems out and see what you can do. To recap, you have 3 inverse trig ratios, sine inverse, cosine inverse, tan inverse. They're related to the trig ratios, but they solve for missing angle measures of a right triangle instead of side lengths. You need to make sure your calculator's in degree mode, and don't forget to put the little -1 and make sure you're closing your parentheses.